this class also. Yes, Ashit. Ashit. Okay, yes, Abir. Assalamu alaikum.
Welcome, sir.
How are you? How are you? So today Tejasvi's mood is good, so we can ask lots of questions to Tejasvi, right?
Yes,
Okay,
sir.
so yeah, so now we have usual Tejasvi that we are what should I say? So that we are aware of, right? Or okay, Hashid, maybe Hashid has joined and then okay. So now what we were doing, we were doing the probability, right? So, oh, I just wrote this probability and then we didn't do anything.
No, sir.
Good. So now let us revise or recap in your ninth class. What did we learn about the probability, right? So we learned that probability of an event is what it is favorable outcome and divided by the total outcome, right? So this we have learned in our 11th, 9th class, right?
Yes, sir.
So now let us talk about what are the conditions or what are the scenarios that we have. So first is tossing a coin, tossing a coin, 2 coins, right? Or maybe 3 coins. So we can toss it simultaneously or we can toss it 3 times. So whatever the result would be same, right? And the second is that second type of question is about let's say dice, right? So rolling of a dice or 2 dice, 2 dice or 2 dice, 2 dice. And then the third one is card problem, right? So these three we will extensively study about. Right. So first, let us talk about the coin problem. So let's say that we have a coin. We toss a coin, right? So how many scenarios would be there?
Two.
So two, right? So we can either get head or we can get tail, right? So there would be only two scenarios. If we toss a coin, we can either get a head and we can either get a tail. But in this whole chapter, we'll do the unbiased analysis, right? Unbiased meaning that all the coins or all the die or all the cards that we do, those are unbiased. Unbiased meaning that let's say that you have a coin and the coin has higher mass in some region. So that part will always come. So that is a biased coin. But in our case, the coin is symmetrical. So it can give both the results at the same time, right? So that is why our coin is unbiased, our die is unbiased, and card is also. So we are, in our case, in this chapter, we will do the unbiased analysis, right? Okay, so for the unbiased case, we can get head and tail, right? If the coin would have been biased to this head only, so all the time we will toss and then we'll get the head all the times, right? So you guys have must have seen the movie Sholay, and and Amitabh Bachchan had a coin, right? And in that toss of coin, he always used to win that bet because his coin was biased, right? So, but our coins are not biased. Okay. So the total outcome is how much?
Two outcomes.
So total outcome is right. And if I for head getting ahead, so getting ahead, how many favorable outcome?
One.
One, right? And getting a tail, how many outcome?
One.
One. Getting a polar bear, how many outcome?
Zero.
Zero. And getting either head or tail, how many outcome?
One.
So both
Two.
we can
Two outcomes.
work. Good. So now probability of getting a hit. This is 1/2. Probability of getting a tail. This is 1/2. Probability again of getting a polar bear, right? So why I'm saying this, you guys will understand it. This is 0 and 0/2. And probability of getting either hit or tail. This is 2/2. Right. So these kind of probability where all the scenarios have equal chance. So that is called the elementary outcome, right? Elementary effect. Elementary. Okay. And if I'm getting a zero probability, so this is called an impossible. Okay. And if I'm getting a probability 1, so that is called a certain, certain or sure. Understood, everyone? So when I tossed a coin, and so there is 100% chance that I'll get either head or I will get a tail, right?
Yes, sir.
So that is why I'm saying that a certain or sure event. And you are tossing a coin and asking about a polar bear, right? So that is an impossible event. You are tossing a coin and then you are asking about a polar bear. So the probability of getting a polar bear is zero. So that is an impossible event, right? And probability of getting a head, probability of getting a tail, all these have equal chances. So 1/2, 1/2. So that is why we are calling it an elementary, right? Is this part clear, everyone?
Yes,
Yes,
sir.
sir.
Yes,
So,
sir.
so what is the minimum probability that I have got? What is the minimum probability,
Zero,
Zero.
right? And maximum
one,
1. So the range of probability, right? So the range of probability of an event is from 0 to 1, right? So whenever you see that probability of an event is 3/2, so can this be a probability,
no,
No, sir.
right? Because this is 1.5. How can probability be greater than 1, right? So yeah, this is the terminology of probability. Okay, right. And the second thing is that the second thing is probability of not getting the event, right? P not E. So let's say that I have tossed a coin and I'm asking that probability of not getting head. So that is how much? That is again 1/2, right? So this is 1 minus probability of getting an hit. Okay. So probability of not getting an event, this is always equal to 1 minus probability of that event to be happening. This is the relation between P not E and E. Is this part clear?
Yes, sir.
Yeah. So when we will do the die problem, then we'll also see that why this not E is 1 minus. So you guys please note up to this point, and then this part is not needed. This part is already. So note about this point. Elementary event, impossible event, and certain, and the range of probability. So these are the three crucial points.
Noted, sir.
Okay. And this one. This one is very important. Please, so this one and this. Whenever you guys have noted it down, please tell.
Yeah, noted, sir.
Done, sir.
Noted. Tejasvi and Amila, what about you guys?
Done, sir. Noted, sir.
Okay, so now let us toss 2 points. Right, so what are the outcomes? Let me tell the first outcome. You both, in both the coin, you get head. So this one is the first. What is the other one?
In both we get tails.
Okay, so in both we get, so Abir has told. Now, Amira, you tell me the next one.
Head and tail.
Head and tail. And Tejasvi?
Tail and head.
Okay, so good. So will there be any other possibility?
No.
No, sir.
So we have only 4 outcomes, right? We have 4 outcomes. And if I ask you that probability of getting 2 heads, right? So that is how much? That is 1/1,
1.
right? And if I ask you that probability of getting at least 1 head, so at least 1 head, what would be the probability?
3/4.
Tejasvi, 0,
3/4, sir.
3 by 4. Okay, so Abir is saying 3 by 4. Tejasvi and Amira, what is your answer?
3/4.
4, sir.
3 by 4. Okay, so all of you guys are in agreement, right? At least, meaning that at least we have to get one head, and after that we can have two heads also. So one head is this, one, two, and then we have this two heads. So 3 by 4, right? And if I ask you that, what is the probability that I get head and tail both, right? So both H and so how much is that?
2/4.
2.
By 2 by 2, right? So this is 1 by 2. Okay, good. So now you guys have tossed 2 points. Now let us toss 3 points. So 3 points tossed. So let me write the first one, right? I will write the easy one. And Tejasvi, you tell me the next one.
TTT.
Oh, okay, good. And now Amira, your turn.
HTT.
HTT. Where does this go? HTT. And Abir,
HHT.
HHT. And then Tejasvi,
THT.
THT. And then Amira,
TTH.
TTH. And next one, Abir.
T. TTH.
TTH is this, right?
THH.
THH. So THH is not. Right. So will there be any other? Yes. So I will tell you guys a simple trick. So whenever these kind of question has been asked, 3 points. So you write H 4 times. Okay. And then you write tails 4 times.
Sir, HTH is not done.
HTH. HTH. So you were counting. Yeah. So will there be more? Okay. So I am telling that first you write H 4 times and then T 4 times. And then you write H 2 times and then T 2 times. Then H 2 times and then T 2 times. And then you write alternatively. So H, T, H, T, H, T, H, T. So you guys can count that, and this would be the total outcomes. This you write 4, then you write 2, and then you write 1. So total is how much?
Total 8 outcomes.
What happened, Abhi? Are you all right?
Yes, sir. Total 8 outcomes.
Total 8 outcomes, right? Okay, so yeah, total outcome is 8, right? And if they ask you also, these are the total outcome, right? And on the basis of this, they will ask you questions. So please, you guys, note down this part because this is important, and then after that you can solve any kind of question. So if I ask you that, what is the probability of getting two heads? Right, only two heads. So then what is the probability?
So how do you get total 8 outcomes?
So this is 1, 2, 3, 4, 5, 6, 7, 8, right?
Oh, okay.
But this is the counting that I am doing. So 4 times h, 2 times h, 1 times h. So that is what, this is the trick that I have, not the number, right?
Okay.
Okay. So yeah, what is the probability of getting 2 heads?
Sir, at least two heads?
No, at least, not at least, but only 2 heads.
Two outcomes, sir.
So 1, 2, and 3, right?
Yes, sir.
Right. So 3 by 8. Okay. And yeah. So okay, you guys please note it down and then we'll do the dice problem.
Done, sir.
Done. Abir and Amira, what about you guys?
Done, sir.
Okay. So then we have a dice problem, right? So rolling one die. Okay. So what can be the outcome? One would be 1, 2, 3, 4, 5, and 6. Right. So these are the outcomes that we can have. So total outcome is 6, and probability of getting 1 is 1 by 6. Probability of getting 2 is 1 by 6. Probability of getting 3 is 1 by 6. Similarly, 6 is 1 by 6. So you guys can see that all these events are what? Elementary events, right?
Element.
Yes, absolutely right. So all these are elementary events, right? Okay, so this
Yes, sir.
can happen only one time. So that is what we mean by elementary. And if I ask you to calculate P not 1, probability of not getting 1, right? So this is how much?
5 by 6.
5 by 6. So you calculate it by using 1 minus probability of getting 1. So this is 1 minus 1 by 6, which is 5 by 6, right? So if you add probability of 1 and probability of not 1, so this is 1 by 6 and this is 5 by 6. So this is 6 by 6, which is 1. So this tells us that probability of event plus the probability of not getting that event, that is always 1. So this follows unitary condition. Okay, this one is also important. So is this part clear?
Yes, sir.
Yes, sir.
And if I ask you guys that what is the probability of getting a sum uh, 4? So what is the probability? Oh, no, that cannot happen, right? So when we roll 2 die, then these kind of question may ask. But in rolling 1 dice only, this would be the general questions. Okay,
Yes, sir.
Yes, sir.
because yeah, this part you don't need to note it down, right? This part you already. Now what we do is that we roll 2 die together. So 2 times, right? Okay. Or we can also, so this is simultaneously, but we can also roll it 2 times. Both are equivalent. So rolling simultaneously or roll it 2 times, both are equivalent. So the outcome is calculated by this row and column method. So we have this column and then this is 0. So in column we write 1, 2, 3, 4, 5 and 6. And in rows we write 1, 2, 3, 4, 5 and 6. So 1 and then comma all the thing. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. So this is the first row. And then we have the second row. So and then third row. Okay, so let me write everything. No. Okay, finally we have been able to do the ah do the total outcome. So how many total outcome do we have?
36.
36, right? So 6 columns and 6 rows. So 6 into 6, which is 36. So this is a total outcome, right? And if I ask you that what is the probability of getting same number, right? Same number in both the die. So what are the scenarios in which I get the same number? Yeah,
So
what is
6 by 36?
right? So first
So
one is
1 and 1.
one, then this one, this one, this one, and this one. So 1, 2, 3, 4, 5, 6. So it is favorable outcome is 6, total is 36. So 6
1
by
by
6.
6.
Right. Clear, Amira and Tejasvi?
Yes. Yes,
Yes,
sir.
sir.
And if I ask you guys that what is the probability of getting a sum 5? So you guys calculate and tell.
4 by 6?
4 by 6, 36, 6 or 36.
36. 36.
So Amira is saying 4 by 36, which is 1 by 9. And Amir and Tejasvi,
So 4 by 36.
4 by 36 and
Same, sir.
Tejasvi, same. Good, so everybody is in agreement, right? So this is the This one is the first one, then this one, and this one. So 4 by 36. Similarly, if somebody asks you that how can I get sum of 6? So this one, this one, this one, this one, this one. So in this way, we can calculate, right? These kind of question based on two die, right? So you guys please note down this outcome, and then we'll do the card problem.
Done, sir.
Done. Okay,
Done,
Tejasvi
sir.
and Amira, what about you?
Noted,
Done.
sir.
Okay, good. So now the next problem is about the card problem, right? So let us understand about the cards. So we have in a playing card, the total cards are 52, right? So you guys have played Uno, right?
Yes, sir.
And,
Yes, sir.
and did you guys play this card game?
No, sir.
No, sir.
No, because I used to play card for lots of hours, and the game that I used to play was 28. So that was a very good. So as long as you don't bet in playing cards, that is okay. But when you bet in playing cards, that is not okay. But as long as you don't bet, so you can play cards, right? And the same case for the Uno as well. So okay. So in a card, so have you guys seen the card? Yes.
Yes, sir.
Oh, Tejasvi, you have seen. And Veer and Amira, what about you guys?
Yes, sir.
Yes,
Guys
sir.
have seen. This is a very addictive game. Just like Uno, this is a very addictive game. So in my younger days, I used to play how many years? I don't know how many years. Okay, so in this playing card, it is divided by first. It is divided by two things, right? On the basis of color. So half is red and half is black. So how many there are? How many reds? Yes. How many reds?
1/2.
1/2 of what? So no, I'm saying that how many number of red cards?
13.
Total is
26.
50, 20, right? So did you guys understand TSV and Amira?
Yes,
Yes,
sir.
sir.
Total is 52 and then half is red, half is black. Now this red is again divided in two parts. Okay. And this black is also divided in two parts. So the red one is divided in diamond and hearts. Okay. Like pink, but assume that this is red. and then we have two blacks. So this is diamond, right? And this is hearts. Okay. And then black is divided in clubs. So this is club, right? And then we have these spades. So right. This is club, and this is spades. Okay, and this one is club, and this is spade. Okay. So how many diamonds would be there?
13.
30. So this is 30. And how many heart?
13.
13. How many club?
13.
And spades. Okay. So this is how it is divided. Now again, all these 13 cards, they are again divided in a different way. So in this 13 set of cards, we have first one is the number cards. So this goes from 2, 3, 4, 5, 8, 9, and 10. How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 number cards. Okay. And then we have one ace. Right. And then we have, so how many is this? 9 plus 1 is 10. Then remaining are the face cards. So one is king, the other one is queen, and then we have jack. Okay, so this is how the cards are divided. Any problem or any doubt in this part, guys? Yes.
Yes, sir.
No, sir.
Okay, so please note it down, and this is very important. So you guys know the division. Let me check. Is this club or is this club? So yeah, this is club. Okay, you guys, please note it down and always remember this division. Okay. So, how many face cards would be there, guys?
3.
Face cards total. In this 13, I have 3. In this
12.
13, I will also, yes,
12.
12. So,
Face.
12 face cards. Yes, 12 face cards. Good. And similarly, those kind of question would be, how many aces are there?
4.
4. So, ace is 4. Good. So, these are the kind of question that we may ask. But if we know this tree diagram, then all the questions would be easy.
Noted, sir.
That Shika and Tejasvi and Amira,
Done,
what
sir.
about this part
Done,
as well?
sir.
This part as well.
No, sir.
Okay, you guys already noted down all the parts. Good. So now knowing this, we can now do the question. So let us start from Tejasvi. Probability of an event plus probability of the event not. How much is this, Tejasvi?
1, sir.
1. Good. And Amira, the probability of an event that cannot happen is
0.
0, and such an event is called.
Impossible event.
Okay, good. So, possible. And now, Abhi, the probability of an event that is certain to happen is
Is one.
1, and such an event is called
A sure event or certain event.
sure event or certain, right? Okay, now Tejasvi again. The sum of probabilities of all the elementary event of an experiment is
1.
1, right? And Amira, the probability of an event is greater than or equal to
0.
0, and Abhi, less than or equal to
One.
1. Good, so this part is complete. Now from now let us start from Tejasvi again. Which of the following experiment have equally likely outcomes? Right. So a driver attempts to start a car, the car starts or does not start. Is this an equally likely event? Equally likely meaning 50-50% chance.
Not equally likely.
Okay, so a driver attempts to start a car. The car starts or does not start. So these are equally likely, right? It can start or it may not start,
Okay, sir.
right? Because two things can happen, right? If let's say there is some problem with car, then it will not start. Now, if all the things are okay, then it will start. So
Sir, but isn't there a higher chance for the
start,
car to start?
The car not started.
yeah. So we are assuming that we are unbiased, right? So we are assuming that there is an equally chance that it may start or it may not start. Both have equal chance. So yeah, right. So okay. So did you understand that?
Yes, sir.
So a player attempts to shoot a basketball. She or he shoots or misses the shot. So is this an equally likely outcome?
Yes.
Right. So it is also now I don't. All these are looking like equally likely outcomes. I am
Sir,
assuming that yes.
but what if the player is very good at
Yeah.
playing?
So that is why I'm saying that we are unbiased. We are unbiased judge, right? So we are not looking at the players' skills. So we are assuming that all the players have same skills and okay. So these are some tricky questions. you guys look into the NCRT solution, what they are saying, right? Because from my point of view, these are equally likely, right? It means it may or he or she may miss or she or he may short, right? So both are equally likely outcome from my perspective. But I know,
Sir,
but
but for the third one, it depends on whether the person has studied or not, right? For the true and
yeah,
false question.
yeah. So a trial is made to answer a true false question. The answer is right or wrong, right? So there are two possibilities, right? There are only two possibilities, right? It can be right or it can be wrong. So yeah, it is dependent upon the education or the what the student has learned, right? So it is dependent upon that, but it has only two scenarios. It may be right or it may be wrong, right? I
Yes,
know.
sir.
So this is also looking like a right equally likely outcome, but it is dependent upon the student. So if student knows the answer, then that is a sure chance that he will write a right answer, right? So
Yes, sir.
that is dependent upon. But if we are assuming that that is unbiased, so okay. So you guys see the NCRT solution what they are saying, right? Let me check what they are saying. So I don't know, but from my point of view, it is looking like right. Yeah, you are right, Abhi, that if the student knows the answer already, so he will surely write the correct answer, right?
Yes, sir.
Okay, so what are the biggest question? Yes. eh? Oh, so this is 40. So true, false, true, false. Huh? What is that? This has five questions. This is, oh, yeah, third and fourth. Third and fourth, they are saying that that are equally likely outcome. And one and two, they are saying that it is not an equally likely event. Okay. So if this is debatable, right? This is where these answers are debatable. So yeah, that is depends. But NCRT is saying that third and fourth, they are equally likely outcome. Third and fourth. But Abid, as Abid is saying, it is dependent upon the student as well. So it is dependent upon the other scenario as well. That if the student knows the answer, then he will always write the right answer, right?
Yes, sir.
So from NCRT, this is not, and this is not, and this is equally, and this is equal, right? Because when we are tossing a coin, right? So that is sure shot. We can say that they are equally likely, right? But these have some other factors. So the answer would be debatable. But from NCRT point of view, you write that this is not, and this is likely, right? Okay,
Yes, sir.
okay. So
So,
yeah,
sir, what
one.
do?
Yes, Amira, what are you saying?
So, should we write first? I guess, in my point of view, all the four should be equally likely, but so what should we write?
Yeah, so this third and fourth, these are equally likely event, and these one and two, these are not equally likely outcome, right? So this is a driver, as Tejasvi was saying. So as Tejasvi sir was saying that this is a certain event in context of NCRT answer, right? So all the things are, we are assuming that all the things are working fine in the car. So then it will surely start, right? So that is why it is not an equally likely. So probability of not starting is zero, or probability of yeah, this is zero. So that is why this is not an equally likely event. Similarly, a player attempts to shoot a basketball. She or he shoots or misses the shot. So that is also not an equally likely event. So I don't know why this is not an equally likely, right? Okay, understood everyone?
Yes, sir.
Okay,
So, sir,
so
if
what?
it comes in exams, so what should we write?
Yeah, so you should write that these are not equally likely, right? And these three and four, they are equally likely. So this you should write according
Okay.
to NCRT. But yeah, so you can discuss with your teacher that if this happens, right? If you say that, as Abir was saying, that if the guy already know the answer, then what we are doing? If the guy already know the answer, then what we are doing?
Then it's not equally likely.
Then it is not.
Will always
Then
be
we are.
right.
It will always be right. Then we are biasing the condition, right? We are biased, right? We are biased. We already know that the person knows the answer. Then it will surely be a certain event. So you guys can argue about that part also. But from NCRT point of view, these are first and second not equally likely, third and fourth equally likely. Okay.
Yes, sir.
So I'm saying that these are all debatable questions, right? If these are debatable, that then they may not ask these questions in the exam, right? Because you can debate that the car is not right. Car can have some problems. So yeah, but from NCRT, not yes, yes. Okay, so we will stop at here, and then in the next class we'll do the next set of questions. Okay, we have lots of questions. So what should you guys do? You guys should try some of the questions because yeah,
Sir,
yes.
sir, I won't be able to attend tomorrow's class since I'll be traveling.
Oh, okay, okay. So all is okay. Or
Yes, sir. No, no, no. I'm just turning back to Qatar.
okay, good, good. So then no worries. Then I will not. Yeah, these are the easy questions. So we will do only these parts. Okay, so see you guys tomorrow and safe journey, Abir. Okay.
Thank you, sir. Yes, sir.
Yes.
Allah Hafiz, sir.
Bye, guys. Bye.
Bye, sir.
That's sir.
Bye.
Assalamualaikum.
Walaikum salam. Bye, guys. Bye. Yes. Hello, Ahi. Hello, Ahid. Can you hear me? Yes. Yes. Hello, Ahid. Are you here for the 10th maths class? Yeah, your voice is not audible. So the students are supposed to be Asia, Saleh, and Jamila. So yeah, okay, can you say your name? Hello. Yeah, your voice is not audible. There is some noise in the background there. I cannot hear you properly. So, are you here for the trial class? Just write it in the chat box. If you're facing some problem with your mic, so you can write it in the chat box. We are waiting for others to join. Asia, maybe Asia, Saleh, and Jabila. They will join and then we'll start this class. Okay. 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 So let's wait for them.